Alright, here's the Unit 9 review for the test on Monday. So number one, if we take a look, solve quadratic equation using square roots. We're going to start by trying to get x by itself, so we are going to divide by -3. Those cancel out. X squared is equal to positive 25. And we take the square root. So the square and the square root cancel out, and we're left with x is equal to plus or minus the square root of 25, which is 5, and that's my solution. Okay. Number two, again, solve using square roots. We're going to start divide by -5 this time. Positive 5, those cancel. X squared is equal to -25. When I take the square root of both sides, square and the square root cancel out. But this time I cannot take the square root of a negative, because we can only take the square root of positive numbers, so my answer is no real solutions. Number three, solve the quadratic equation using square roots. So this time I still have a square. I also have stuff inside of a parentheses. Before I get rid of the parentheses, I have to deal with the square. So we're going to start by square rooting both sides. So again, those cancel out. Leaves us with 3x plus 2 is equal to plus or minus. Every time we take the square root, we get plus or minus. Square root of 36 is 6. Now we can make two separate equations. 3x plus 2 is equal to 6. And 3x plus 2 is equal to -6. When I solve each of these, minus 2 from both sides. So 3x is equal to 4 divided by 3. And my first answer is x is equal to 4 over 3. Leave it as a fraction. That's best. And my second equation, again, subtract 2. So 3x is equal to -8 this time. Divide by 3. And again, leave it as a fraction, so I get -8 thirds is my second solution. Okay. Going back up to number 4, solve by completing the square. Remember, completing the square is a way to factor it when it's not factorable. First thing we need to do is we need to make sure this a term is 1. So I'm going to factor out the 2 from these first two terms. So I get 2 times x squared minus 3x. Leave some space, and that's equal to 8. Now this is where I do the completing the square step. So I add a third term. That third term is going to be my b term, which is -3, divided by 2, and I square it. Since I added this extra term inside the parentheses, I have to add the exact same thing on the outside. Remember, it's not just a -3 over 2 squared, it's 2 times -3 over 2 squared. So on the other side of the equation, 2 times -3 over 2 squared. Now I can go ahead and factor this. This will always turn into, we're going to bring the 2 down, and the inside of the parentheses is always going to be in this form, something to the second power, and that something is going to be x and whatever is inside this parentheses, so it's -3 over 2. Always, always, always. That just comes straight down. It's equal to 8 plus, let's see, over here we've got 2 times -3 over 2 squared. -3 over 2 squared is going to give me positive 9 over 4 when I square the top and square the bottom. So this gives me 18 over 4 when I multiply it. And 18 over 4 reduces to 9 over 2. So now the left-hand side I still have 2 times x minus 3 over 2 squared, and that's equal to, I'm going to want to change this to common denominator, so I'm going to turn this into a 16 over 2. 16 plus 9 is 25 over 2, so I get that. Now I can start to solve it. Very similar to number 4, I need to get rid of the square. Also need to get rid of this 2 and what's inside the parentheses. I'm going to start with the 2 that's out front. I'm going to divide both sides by 2. So x minus 3 over 2 squared is equal to, when I divide a fraction by 2, it's like multiplying the bottom by 2, so I get 25 over 4. Now to get rid of that square, I can take the square root. Those cancel out. And x minus 3 over 2 is equal to positive or negative. Square root of 25 is 5, and the square root of 4 is 2. And again, this is where I get my two separate equations. Alright, x minus 3 over 2 is equal to 5 over 2, and x minus 3 over 2 is equal to negative 5 over 2. If I add the 3 halves to the other side, to cancel that out, 5 halves plus 3 halves is going to give me 8 halves, which is 4, and negative 5 plus 3 is negative 2 over 2, which is negative 1. Next, number 5. Number 5 was a little bit tricky. It says your classmate uses the discriminant to determine that the equation has no real solutions. And we're given these numbers, that's all we're told. So part A, use values from the list above to show that your classmate's claim is true. So remember the discriminant from class was the stuff underneath the square root in the quadratic formula, which is b squared minus 4ac. If we want his claim to be true, true meaning that there's no real solutions, we want the discriminant to be less than 0, because we can't take the square root of a negative. So if we find some values for a, b, and c, something that we have to use some trial and error here. So let's say that a is equal to 2, b is equal to 3, and let's make c equal to positive 5. So if I plug those in, I get 3 squared minus 4 times 2 times 5. 3 squared is 9, minus 4 times 2 is 8, 8 times 5 is 40, 9 minus 40 gives me negative 31. Negative 31 is definitely less than 0, so that means that there's no real solutions, which would make his claim true. Okay? To make his claim false, all we need to do is show that the discriminant is greater than or equal to 0. So we need to show that there's at least one solution. So looking at those same numbers, the same values that we have, 5, negative 3, 2, negative 5, 3, and negative 2, this time, again, just picking some values for A, B, and C. Let's make, if we think about this, we want this number here, or we want this B to be the largest value, so it's squared, so that when we take stuff away from it, it's not going to be that big of a deal. I'm going to pick either 5 or negative 5 for B. And then A and C, if I want to ensure that I get a positive value, I want to make sure that either A or C is a negative value, because a negative times a negative is going to give me a positive. I'm going to make A negative 3, and I'm going to make C one of the positive values that I have left. So let's make it 2. If we check that, b squared minus 4ac, 5 squared minus 4 times negative 3 times 2. So I get 25 plus this time, because it's negative 4 times negative 3, that's 12 times 2, which is 24, and that gives me 49, which is greater than 0, so that means there's at least one solution. In this case, there's two solutions. Let's move on to page 2. Number 6, given the quadratic equation x squared minus 3x equal to 8, find the solution to the equation using the quadratic formula. So to use the quadratic formula, we need to have our equation equal to 0. So x squared minus 3x equals 8. We need to subtract the 8 back over here. So x squared minus 3x minus 8 equals 0. And I can use the quadratic formula. So a equals 1, b equals negative 3, and c equals negative 8. And remember, our quadratic formula was x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Start to plug some stuff in. Negative, see b is negative 3 plus or minus the square root of negative 3 squared minus 4 times 1 times negative 8. That whole thing is divided by 2 times 1. This is where I told you guys in class that we need to make sure we are taking our time, being careful. So negative 3 is equal to positive 3 plus or minus the square root. Negative 3 squared is 9, and this right here is going to give me positive 32, all divided by 2. Next step, x is equal to 3 plus or minus the square root of 9 plus 32 is 41 over 2. And this is finished. This problem is done because there's no perfect square that goes into 41. 41 isn't a perfect square, so we have our final answer. So down here in our boxes we have 3 plus or minus the number out front here is just a 1. We're at 41 over 2 on the test. You can leave it just like that. 7. So 7, the problem is actually over here. It's these 4 on the right hand side. So when we look at this, there's four methods that we learn in class: factoring, square roots, quadratic formula, and completing the square. We just need to choose the most appropriate. For us, factoring is either taking out a greatest common factor and then using the zero product property. So we have something like 3x times x plus 2 equals 0, or using the big X and having two sets of parentheses equal to 0. The square root method we use when we don't have a b term. Quadratic formula we use whenever we get like some weird decimal values. And completing the square, remember we said we only want to complete the square if a is 1 and b is even. So that's what I'm looking for when I go over to this chart. On the chart, we got 3x squared minus 9x. I noticed that these two terms have a 3 and an x in common. So I can factor that out and I'm left with an x minus 3. I can set those now equal to 0 and I can solve it. So this is going to be the factoring method, and the reasoning is that I had a GCF. The second one, x squared plus 6x plus 11. If I try to factor this by making the big X, we've got 11 and 6. There's nothing that multiplies to 11 and adds to 6, so I can't factor. But a is 1, b is even, so I'm going to use completing the square. A is 1, b is even. The third one, I could complete the square again because a is still 1 and b is still even, so that would still work. But if I try to make the big X, I get negative 8 and positive 2. And this time I can find two numbers to multiply to negative 8 and add to positive 2. Those would be 4 and negative 2. So I could also factor this. So in this case, factoring works or completing the square works. Either one of those would be acceptable answers. And the reasoning, big X or that still applies. Okay. The fourth one, the first thing I see when I look at this is I've got a decimal value here and a decimal value here. As soon as I see that, I'm going to go with the quadratic formula. I think they used QF. Yeah, QF. And the reasoning, decimals. As soon as we see decimals, it's going to make it really difficult for us to do anything else. So we just complete this, or we just use the formula. And the last one, I don't have a B term. Okay, this just has an A term and a C term. There's no B term, so I'm going to use the square root method. Okay, and there's no B term. That's my reasoning for that one. This is going to be the end of the first video. The second video, we should be able to get through most of, if not the entire rest of the review.